Hi everyone, and welcome to our Constellation Crew live presentation here on Facebook. I'm Dana Thompson, the director of the Brown Planetarium at Ball State University, and I'm joined today with our Constellation Crew, 4 students from Ball State's Department of Physics and Astronomy. We have on screen with us Alec Neal. Hi Alec. Nicolette and
Hi.
Ricky.
Hi.
And we're going to be talking today about a few different things, but we're going to be focusing on the summer triangle. We're going to kind of say goodbye to summer and hello to fall in this episode. And to do that, I actually have the sky here set up to a very special day. We have it set up to not tonight here in Muncie, not this morning here in Muncie. So this is not the sky on September 18th, but it's the sky on September 22nd. And I want you to try to figure out, by looking at this recreation of our sky, what time of day is it? So is this sunrise or sunset? And if you have a guess, you can go ahead and put it in the chat. There's someone else in the chat with you today, another student. So I mentioned there's 4 students today. There is a student going to be helping with any questions in the chat, and his name's Caleb. So if you're watching, if you're just joining us, we're trying to figure out what time of day is it. Is it sunrise or sunset? So we have on our simulation, in our simulation here, we have our sky, and we have where the sky meets the ground. We have our horizon. And on our horizon, we have these letters here. We have S for south, SW for southwest, W over here for west, and then E for east. And I don't know about you, but it looks a little bit brighter on the side by east here than it does over in the west. And so if it's brighter in the east, that's probably where the sun is in the sky. And it's not up yet, there's still stars in the sky, but it looks like the sun might be just below the horizon here in the east. So sunrise or sunset, we have a couple people guessing. We have Dan Malone from the Muncie Astronomy Club. Hi, Dan. And then Luke Mitchell, who actually did the music for the intro, if you're watching the Starting Soon video just before we went live here. So they both say sunrise, because where does the sun rise in the morning, crew?
Rise in the east.
It rises in the east, yeah. And Melanie and other people remember this. So Melanie's one of our other students who's not with us today because she is observing. She's on one of the telescopes that Ball State has access to. So she is observing right now. She wishes she could be joining us today. This is actually kind of her idea of saying goodbye to summer with the Summer Triangle program tonight. But anyway, she says that you can remember where the sun rises by remembering it rises early in the east. Early starts with E, and so does east. So it is sunrise in our simulation here. And just before the sun rises, if you wake up that early, or if you're still up from the night before and you look towards the east, you can see this really bright object, brighter than anything else in the sky, unless the moon's up. And that is this object right here. And that looks like a star, but it's actually not a star, it's a planet. And it's been in the news this week because they found something really interesting in the clouds of this planet. Well, this is the planet Venus. Venus is the brightest object in the sky unless the moon's up, and of course the sun. But just so we don't lose Venus here, here's our label for it. So right before sunrise, you can see a bright object in the east, and that is Venus, planet Venus. So why has Venus been in the news? Well, let's take a trip to Venus and learn more about the planet to see. So here's Venus. This is kind of what Venus would look like up close. And sometimes you see Venus in different ways. Sometimes you see it like this. Sometimes it looks a little bit more orange. Nicolette, what did you say it was kind of colored from what you remember? What was the color of it from what you usually see?
It was kind of a combination of orange and yellow, but it was more towards the yellow side. All textbooks make it look really bright yellow and orange, like
Yeah.
fire. So I always thought it was like a fireball or something when I was little.
Yeah, so when you look at it through um, in different ways, if you kind of peer through the cloud tops of Venus, then you can see the surface. And it's usually depicted as really bright yellow, kind of like fire. It almost looks like the sun. But if you were to actually be at Venus with a spaceship looking down at it, you'd see something more like this because Venus has clouds. It has a really thick atmosphere, 100 times thicker than our own, and it has immense, these just like great layers of clouds that surround it. And so let's get a little bit closer to this atmosphere and these cloud tops because astronomers found something really interesting in these clouds. They found a molecule called phosphine. And that's exciting because this molecule is usually created, by organisms on Earth, microbes on Earth. So this was kind of what we can imagine the molecule looking like in the cloud tops of Venus. So they detected phosphine from Earth's ground-based telescopes, two of them actually, the ALMA Observatory and the James Clerk Maxwell Telescope. And they were able to, with these telescopes on Earth, look at the light being emitted actually by Venus, by the clouds of Venus, and determine that there's this molecule there that's blocking some of the light that's being created by Venus. And reflected sometimes by Venus. And they found that this molecule is present in great amounts. So on Earth, phosphine gas is only really made industrially or by microbes that thrive in oxygen-free environments. So there's life on Earth where there's not really any oxygen. And so there might be some life found on Venus, which is pretty exciting. The cloud tops of Venus have always been speculated. People have speculated that this is an area that we might be able to find life because on the surface of Venus, it's really, really quite a harsh place. So I said that the pressure, the atmosphere is about 100 times thicker than what we have on Earth. But at the cloud tops of Venus, it has a similar pressure there to what we feel on Earth's surface. So the pressure is kind of nice here. And then also the temperature is a lot nicer at these high altitudes on Venus than what is on the surface of Venus. So on the surface of Venus, crew, do you remember or know what the temperature is on Venus's surface?
It's about 800, 900 degrees Fahrenheit.
Yeah, it's like 800 degrees Fahrenheit. It's incredibly hot. And it's hot enough to melt the landers that we've sent to Venus, and it's hot enough to melt lead. So it's just not a really nice place for life like us anyway. But it could support some extremophiles. But at the cloud tops, where they're finding this phosphine, this molecule that's created by microbes that thrive in oxygen-free environments on Earth, at the cloud tops, it's about 85 degrees Fahrenheit. So it's much more temperate there. But it's still really windy there. It's still acidic as well at this location. But it's an exciting thing because that molecule is really only been detected in high amounts by being formed by microbes that, again, thrive in oxygen-free environments. And there's not oxygen, or a lot of it anyway, on Venus. So could it be formed by other natural processes? Yes. But if it was formed by volcanoes on Venus or by sunlight hitting Venus's atmosphere, that would only account for 1/10,000th of the amounts of phosphine detected. So they're finding it in huge quantities. Well, we can't really take a sample of the atmosphere of Venus and study this up close. We've just been able to observe the light being reflected by Venus and being emitted by Venus to make this discovery. But maybe we will need to send a rover there one day or a spacecraft there one day to take a sample, and we can study it more. So it's really exciting, but no one is saying that there's aliens there yet, anyway. Well, maybe Nicolette and Ricky are, but I don't know. I'm not saying there's aliens there. All right. So we are going to talk about the summer triangle today. And again, we're going to kind of say goodbye to summer. And so to do this, we went to a special day. Just a couple of days from now, a few days from now, September 22nd. On September 22nd, we have something, happening with the sunrise and sunset locations. And I'm going to go ahead and speed up time so that we can see a whole day and see what's special about September 22nd. So here we go, speeding up time. And it is sunrise, so the sun is going to rise early in the east there. And we're going to let the sun leave a little trail so we can see where it rose in the sky and where it's been and where it's going to set. So what makes this date, September 22nd, special, Ricky?
Well, September 22nd is going to be special because that's the equinox. So it might be kind of hard to see in the video, but the sun on the equinox is actually rising due east, directly east, and it's going to set directly west. This only happens twice a year on the equinox. So what a lot of people might not know is that the Earth is spinning on its axis kind of tilted. So as it orbits the sun, one hemisphere is closer to the sun and the other hemisphere is farther away. It's closer during the summer and farther away during the winter. But twice a year, the Earth kind of comes up broadside to the sun. And those are the equinox days. And the effect of that is that it's going to come up directly east and set directly west for almost anywhere on Earth, except for the poles, because there's no concept of east or west when you're on the poles. And a big side effect of this is that the days and the nights are going to be the same length. Another kind of neat thing about it is if you're standing on the equator, this is the day that the sun at exactly noon is going to be directly overhead.
So like local noon or solar noon?
Well, it should be
I don't
solar.
remember.
It should be solar. It'll be at your zenith at noon.
It's solar noon
It
for
should be
sure,
your
but I
actual
don't know if
noon.
that matches their actual clock, like noon.
Well, if you're on, I guess if you're actually on the exact line,
Some point in the day,
might
you'll
match
see
up,
it directly.
but it'll be like a couple minutes off if you're not.
Yeah, midday, you would see it high in the sky for sure.
Mm-hmm.
Highest in the sky. So you don't see it directly overhead ever here in Muncie. It only gets so high above the horizon. But on the equinox, it rises exactly in the east and it sets exactly in the west. And I always remember or have been told that the sun rises in the east and sets in the west, but that's not actually accurate. The sun sets in the eastern sky and it sets in the western part of the sky. Because sometimes it rises south of east and sometimes it rises north of east, depending on what time of year it is. But on the equinox, which is September 22nd, it rises exactly in the east and it'll set almost exactly in the west. So I don't know if you got to see a little bit of the ground while we were going through our day here, but we were on a certain location on the Ball State campus. So if you if you figured out where we were on Ball State's campus, go ahead and put that in the chat. We'll add it to the chat after the program ends where we were. But let's move our focus to the object of the week, which isn't really a constellation, but something else. So let's bring our view in our simulation here a little bit higher in the sky, because this object is actually almost directly over your head, right after sunset this time of the year. And it is the object of the week. It is the Summer Triangle. And again, it's not one of the 88 official constellations, but it's something else. Ricky, remind us what that is.
Well, it's an asterism. So kind of like how we went over last week, it's not a constellation. An asterism is any group of stars that you can kind of see and make out, and you have a colloquial name for, but it's not an officially recognized constellation. So these would be things kind of like the Big and Little Dipper, or our Summer Triangle here, or even like the Northern Cross, which is kind of cool because it's in the Summer Triangle, and they kind of share one of the stars. So the Deneb is one of the vertices of the Summer Triangle, but it's also the head of the Northern Cross.
Okay, so let's see what some of those look like. Okay, so the Summer Triangle, it's made out of 3 really bright stars. In our simulation here, we have a lot of stars because we're showing the sky without really any light pollution, any light that makes it difficult or impossible to see some of the stars that are actually in our sky. Whereas in real life, we have light pollution, especially on campus here, and you can really see these 3 bright stars directly overhead after sunset, and they make up something called the Summer Triangle. So why is it right overhead after sunset when it's going to be fall? Well, it's called the Summer Triangle because it's up all night long in the summer. And it's made from 3 really bright stars, like Ricky said. There's Deneb, there's also Vega and Altair. Well, let's go ahead, connect those dots, and we do see that they do make a triangle up all night in the summer, so we call it the Summer Triangle. Really easy to spot, but not one of the 88 official constellations. It's an asterism, just another easily recognizable object in the sky. And as Ricky mentioned, there's another asterism in this part of the sky. There's the Northern Cross, where Deneb is the top of it. All right, so we can actually expand this region where the Northern Cross is and see even more, right, Alec?
Mm-hmm. Yeah, so the Northern Cross is actually part of a constellation called Cygnus, which is related to the Greek word for swan, and Latin.
Okay, so really quick before we hear more about that, Alec, let's bring up the pictures here so that people have an idea of what we're seeing. So the Northern Cross there, you can kind of imagine it as a swan. So if we kind of extend the lines here, you can maybe start to see a swan. And if you have a really good imagination, you'll see all of that. I don't have a good imagination, so I just see I see the cross usually. And Altair is a part of another group of stars that looks like an eagle. And then we have Vega, that's a part of a group of stars that looks like a harp. So Alec was mentioning that Deneb is a part of a constellation called Cygnus the Swan. Tell us more about that, Alec. Go ahead.
Yeah, so contains Deneb, like was mentioned earlier. Deneb is the 19th brightest star in the night sky. But another cool star system in Cygnus is Albireo, which is a binary system, and you can actually see, you can't see it with your eyes, but if you were to look through it like a telescope, you would be able to make out 2 stars. And what's neat about them, as you'll see in a bit, is that they have 2 distinct colors. So you'll see one that's sort of looks sunnish, so it's amber roughly, and then there's a blue one, So the thing with stars is that the way that we estimate how hot they are on the surface is actually related to what color they are. So um, it might be counterintuitive to think, but hotter stars are actually bluer. And colder stars are actually redder. I mean, they're not cold. It's still like several thousand degrees.
Just less
But
hot. Yeah.
yes, it's less hot. And the big bright one that's the amber color, um, it's actually larger than the bluer one, but that's because it's more along on its life, so it's kind of gotten bigger and swollen. But it's about 25% colder than our sun, and the blue star is from 2 to 5 times the temperature of the sun, that's pretty hot.
Cool. So we have this star that looks like, well, it looks like one star in our sky with just our eyes, called Albireo. But if you were to look at it in a telescope, you actually see something similar to this picture here. You see two stars. So it's what we call a visual binary. I'm not sure if it's a true binary system. I can't recall. Alec,
Yeah, there is some speculation that it's just an optical double, which is just they happen to be two stars that are my hand's just weird, that are next to each other in the field, but they're not actually orbiting around each other.
Yeah.
So they're not. They're kind of just.
They're kind of like in the same line of sight or so.
Yeah. Mm-hmm.
Yeah, but maybe they're not gravitationally bound to one another. But it's really a nice object to look at because you can see color actually with a pretty basic telescope, I think. You can definitely see some red color for the star here and then a bluish tint to the other star. And the blue stars are really, really hot. Red stars are very hot too, just not as hot as the blue stars. So blue stars are the hottest stars, red stars are the least hot stars out in our universe. All the other colors are kind of in between that.
For reference, the sun, is a very pale yellow. It's pretty close to white, actually. So
yeah, it's like a peach color, like a whitish peach color is what I heard it be referred to as. Yeah. Yeah, that's really exciting. Albireo is actually one of my favorite stars because it was the first object that I saw through a telescope and thought, oh, wow, that's actually pretty cool. I mean, I think I saw Saturn growing up and other planets growing up, but this, with seeing actual color without having to take a long exposure image, like that was really exciting for me. So Albireo is definitely one of my favorites. All right, so what do we have next here? There's something else in Cygnus. So just a reminder that we were just looking at this star right here, Albireo, which looks like one star to us in our sky, but with a telescope, you can see the two. There's something here that we can't see with our eyes, and you can't even really see with the telescope because it's really quite interesting. Ricky, you're going to help us learn about that, right?
Yeah. So it's actually, we think it's another black hole called Cygnus X1. So we discovered this in 1964 because something in that part of the sky was emitting X-ray signals. It was doing it regularly, and so we figured it out, and we could kind of, from those X-ray signals, figure out that it had to be smaller than the sun, but from some of the other light sources and stars in that area, we could find out that it had to be about 15 times more massive than the sun. And those two numbers don't really jive well with each other unless you have a black hole. Um, so we think it's black hole. And then later on, we kind of narrow down those numbers. And you can think about how the next densest object that we know of is a neutron star. But you can't have a neutron star that's more than 3 times as massive as the sun. They just kind of die. They collapse and become black holes. That's kind of the cutoff point. So actually in 1974, at the end of 1974, Stephen Hawking made a bet with Kip Thorne about whether or not it was a black hole. And Stephen Hawking, famous for all his research on black holes, bet that it wasn't. And he said the reason that he bet that it wasn't was that if it turned out that he had wasted his life and black holes don't exist, he'd win his bet. But otherwise, he'll win the bet. He'll lose the bet.
So it's like a win-win
And
situation.
yeah, it's a win-win situation for him. He'd lose the bet, but all of his research is validated. And it actually took 25 years for them to quell the bet. In 1990, Stephen Hawking admitted it's a black hole, and the story is he kind of broke into Kip Thorne's office in Russia and took the signed piece of paper that they made the bet on, and he signed it and said, "I lost."
I don't know. What do you think? Like, would you rather lose a bet, or wait, no, would you rather win a bet or have your life's work validated?
I would like to do both, but if I had to choose, I would rather have everything I've done mean something.
You should have gone for broke.
Yeah.
Gone with one way or the other.
Yeah. Yeah, he should have, with him especially, he should have had more confidence in himself. So, but that's good. It's a good anecdote. So this image here, this is an actual picture that was obtained using or collecting X-ray light from this area in the sky in Cygnus the Swan, right around here. So you couldn't see this object in visible light, so light that we see with our eyes. But let's see what it might look like, or this region might look like up close. So there's an artist's conception of this area. So fading from the one X-ray view of the black hole, Cygnus X1, to an artist's conception here, it kind of gives an idea of what might be going on. There's this really massive star that's maybe getting taken in, and there's X-rays being produced by the really energetic activity happening by the black hole. Ricky, did you have anything more to talk about with that?
Not really, but the only other thing was another anecdote that it is being orbited by a giant blue star. So it's blue. It's got to be really hot because it's blue.
True. Very true. So hot blue stars. All right. Well, we have lots of other stars in the sky here. The three that we're highlighting, Deneb, Vega, and Altair, they make up the summer triangle, which is a topic that we're focusing on tonight as we say goodbye to summer and hello to fall. So the summer triangle is up all night long in the summer, but it is still high in the sky directly overhead right after sunset, even late into the fall. So we're going to learn all about it so you can find it in your sky and figure out what else is there. So let's move on to, we just were focusing on Cygnus the Swan here. So Deneb makes the tail feather of Cygnus the Swan. Let's move on to Altair down here in Aquila the Eagle. And Alec, you're going to teach us some things about that area of the sky.
Mm-hmm. Yep, so the constellation Aquila is Latin for eagle, and it contains the very bright star Altair, as she mentioned, and it also means the eagle. It's derived from probably Arabic and stuff like that. Other depictions of Aquila, are that it's carrying an unfortunate guy, and he's carrying him to his doom or something like that on his talons.
Yeah, like a lot of the constellations, they have stories behind them. And so Altair, which is a part of the constellation Aquila the Eagle, there's this whole story about how the eagle might be carrying people with its sharp talons there. And there's a lot of other stories or myths that go with Cygnus the Swan too, and so on. And we're going to actually be hearing from Nicolette on one that's associated with the star Vega, and the constellation that it's a part of, Lyra the Harp. But before we go on to that, there's an interesting object in Aquila the Eagle that we have a picture of here. And Alec, you're going to talk and explain what this is, because this does not look like a star, right?
Yeah, so it's a planetary nebula in Aquila. So it's really probably an exploded star, and it's just a remnants of that. And so just imagine, exploding the sun, you're gonna have a bunch of stuff flying around. So
yeah, and we're actually going to see a planetary nebula later on with Nicolette. I thought this was a protoplanetary nebula.
Oh, is it?
I can't recall. But maybe Caleb can look it up and see. It has a really hard to remember name. It's called IRAS, IRAS 19024 plus 004. I'm not going to repeat that.
Wow.
We'll get to it. We'll talk about it in the chat later, and we'll try to clarify, is it protoplanetary or planetary? Did you already
anyone has, well, I was just saying, if anyone in the chat has any recommendations for names, that would be appreciated.
Yeah, I thought it was like lily pad, maybe.
There's this thing that says starfish in the sky.
Yeah, astronomers like to see things in what they
kind of looks like a butterfly, actually.
Yeah, there's already a butterfly nebula, though, and a bug nebula.
Oh.
It could just be a starfish without a limb.
I see five. I see five little things.
Okay.
So there's one.
I just could not.
3,
there we go.
5. Yeah, starfish. Cool. All right. Well, there are the 3 bright stars that are each a part of the summer triangle, but they are also each a part of a constellation of their own. Because the summer triangle, remember, is not a constellation. It's an asterism, just another easily recognizable group of stars in the sky. Really easy to see after sunset high in the sky. But if you find them, you can find 3 constellations just by finding a simple triangle in the sky. So we have Deneb in the constellation of Cygnus the Swan, Altair in the constellation of Aquila the Eagle, and Vega is in the constellation that Nicolette's going to talk to us about next.
Yes. So this constellation is called Lyra, Lyra, and it's actually pretty interesting. It's mainly about the instrument from a Greek musician and poet called Orpheus, who was married to, I believe, Eurydice. I believe that's how you pronounce her name. So it's his instrument. It's called a lyre, or it's technically a harp. You can see the constellation image there. Obviously, you're not going to see the harp in the sky. However, that's what the harp or the lyre looks like. So the origin story kind of behind it is that Orpheus, for many different reasons, again, with these stories, they come from many different regions and different areas, so there are multiple stories with multiple endings. But the main gist is that Orpheus was dying, and upon his death, he decided to throw his instrument into a river. Zeus heard word and sent an eagle to go retrieve the lyre so that he can put it amongst the sky. Now, talking about the eagle, it just recently clicked in my mind during this talk that while I was doing this research, Zeus wanted to put the lyre and something else in the sky. A lot of researchers were talking about both, but I couldn't figure out what both was. Orpheus and his instrument, but it could be that maybe the eagle is the harp that they were implying. I'm not sure, but it just came to mind since Zeus specifically sent an eagle to retrieve the instrument from the river. So battle it out in the comments, I guess. So that is the origin story. behind it, there's actually some interesting things going on in this constellation. So first we have Vega, which is the fifth brightest star in the night sky. There's also a couple of other things. One of them is the Ring Nebula, which is actually very pretty.
Okay, so before I bring up the Ring Nebula, if you look kind of at this shape here, what is that, a parallelogram? It's been a while since I've did my shapes. So our parallelogram here, these two stars, there's a space in between them, and it looks like there's nothing there, but with a telescope, we can actually see that there's all of this. So what is this, Nicolette?
This is the Ring Nebula, and it's actually quite beautiful. Alec mentioned earlier that the previous nebula we were looking at is a planetary nebula. This is another planetary nebula, and this is basically the remnants of a star exploding, like Alec also mentioned. That's usually how planetary nebulas are born. So to clear up a common misconception that I recently had, this does not mean that this nebula creates planets at all, since it's an aftermath of a star explosion. So this is not like the common pretty nebulas that you see everywhere that everyone says are the birthing grounds of stars and planets. It's quite the opposite. So in the center, you'll notice that there is a dot there. That is a white dwarf star. So what happened, or most people speculate happened for the Ring Nebula, is that this is the aftermath of a red giant that recently expanded towards the end of its life and then turned into a white dwarf. This is common amongst stars that are very similar in size to our sun. So this is a possibility for our sun.
Cool. Okay, so this is a planetary nebula. And we heard from Caleb, one of the Constellation crew members in the chat, that the nebula that we showed before is known as the Dragonfly Nebula. So not a starfish, but dragonfly.
That makes sense.
Yeah, okay. I guess I see it. And it is a protoplanetary nebula. So it's kind of before what this one is. In between a red giant star phase, the red giant phase of stars, to the planetary nebula that we're seeing here.
Okay, so this is the official aftermath then.
Yeah, I mean it's still evolving. It's probably like this gas that, you know, once was a part of a star like our sun. It's still growing out from the central region here. So stars like our sun, they die. Stars die all the time. And our sun will die in about 5 billion years. But before it does, it gets really large, really red. And eventually it pushes off its outer layers of gas out into space. And that's what we're seeing here in these beautiful colors. But the core collapses into what Nicolette was talking about, the red dwarf here. And I don't know, did you mention the size of that, Nicolette?
The size is, I believe, slightly bigger than Earth.
Yeah, so our sun is 109 times wider than our Earth. And it goes from being something that large, it actually gets even larger before it dies, to being the size of our planet, Earth. So the white dwarf star here is really quite small for a star. It's about the size of our Earth, if not just a little bit larger.
Yes, it is also very dense. It's a very dense star.
Yeah, a lot of that mass, it collapses and it creates this dense object, this white dwarf star. And scientists thought for a long time that there couldn't be anything that would survive this. So, you know, in our solar system, we have the planets, we have asteroids, we have comets going around our sun. And if our sun went through this process, a lot of those would be destroyed, either ripped apart or engulfed by the dying sun. But they recently, this week, another exciting thing in the news was that they found a planet going around a white dwarf star. Scientists actually observed a planet, which is depicted in purple here for some reason. I don't really know if planets, I don't know. I wonder what molecules would make a planet purple. So this is not a real picture. This is an artist's conception of a planet, a gas giant planet, going around a white dwarf star. And they detected this using the telescope that's being used to find exoplanets, planets going around other stars now. That's called TESS. For a long time, we had Kepler, which, if you remember, it actually was looking at a part of the sky by the summer triangle. Well, Kepler stopped working, and technology evolves all the time, so we sent another spacecraft out into space called TESS. And with TESS and another telescope called the Spitzer Space Telescope, they were able to find that there is this planet going around a white dwarf star. And this is really exciting because this actually will help astronomers be able to figure out the composition of the planets a little bit better, the characteristics of the planet. So, like, what's the atmosphere made out of, and everything like that. It's just easier because the planet's much larger than the star that it's orbiting, so it's a little bit easier for them to detect some of those molecules and determine the composition of the planet. But they've only found one so far. They have to find maybe more and figure out more about the exoplanets like this, which I think is pretty exciting. Because once they know at least one exists, then a lot more people are going to be looking. Kind of sparks the exploration.
It is kind of interesting that it is a gas planet so close to a star, because normally we talk about how it has to be very cold, and that's why Jupiter and everyone else is so far away.
Yeah, so this is like a planet that is 7 times larger than the host star, the white dwarf star. And it's going around extremely fast. It goes around once every 34 hours. That's 60 times faster than what Mercury, or how fast Mercury goes around our sun. 60 times faster than Mercury. And usually material that gets this close, planets that get this close to a massive object like a star, they get torn apart. And usually that material is just pulled apart by the gravity of the host star, and it turns it into this disk of debris. So it's not likely, it's not very common to find, they haven't really been able to find planets going around stars like this, not this close in anyway.
Right.
Yeah, and also it's usually hotter close to the star, and gas doesn't really like to be hot. It likes to expand when it gets close to those high temperatures, and that's why when we do find gas planets close to their host star, we often refer to them as hot Jupiters.
Yes, that's where the term comes from.
Yeah.
Okay.
So, a lot of interesting science there, though. Oh, Alec, I keep forgetting that you have one more thing that teaches about. Go ahead and pause it here. Or actually, I'll let it play once.
Yeah.
There we go. All right, so something else in Lyra the Harp.
Yeah, so there's a sort of group of stars called Beta Lyri, and it actually contains 6 stars in the little region, but specifically there's a star that kind of looks like this. Well, it's 2 stars actually, and what they are binary stars, and they are situated relative to us so that we can see one of the stars actually pass in front of the other and block some of its light. But what's cool about these, they're called eclipsing binaries because they're eclipsing each other, sort of like, we eclipse the moon or the moon eclipses us from time to time. These are neat because you have one star that is transferring matter. You can see that sort of stream going along to the white star, and sometimes that mass transfer can get in front of one of the stars and actually distort the light coming from us, so it'll complicate things.
So that's in the constellation Lyra the Harp, right? So there's,
Yep.
was it like the first one that was found of that type?
Yeah, so the actual variable star type Beta Lyri, so it's like the namesake for that. So that's pretty
All right,
cool.
so Beta Lyri is this one right here.
Yeah. Mm-hmm.
Yeah.
Yep.
And it's, Beta, so second brightest in the constellation, right? Alpha Lyri up here, and then Beta Lyri. So one of the brighter stars of the constellation is actually what? You said 6 stars are in this small region of the sky?
I think so. That's what I saw.
There's a number of stars, basically in this region of the sky, and 2 of them are so close that there's actually a transfer of material between them. And scientists observe the light coming from that region and can infer a lot of interesting things about it. All right.
I guess specifically why it's doing that. Why does one star get to have all the mass and this one's losing it? It's generally because one star becomes so big that it kind of can't hold all of its mass. So the other star that's got its stuff together, I suppose, starts getting some of the matter that's not so tightly bound to the very big one. So that's why.
Okay. So like structural integrity or something is compromised. I don't know.
Right, yeah.
Cool. That's really, really interesting. There's so much more in this very small region of the sky. But I think the big takeaway is to try to go outside after sunset safely and look up. And you should see these 3 really bright stars, Deneb, Vega, and Altair. And again, if you find those 3, you found 3 constellations. You have Cygnus the Swan, you have Aquila the Eagle, and Lyra the Harp. But if you just want to find the 3, you'll find the Asterism, the Summer Triangle. Up all night long in the summer, but still visible high in the sky after sunset into the early fall. One of the easiest things to find in the sky. And a lot of people, they usually can find Orion the Hunter or the Big Dipper, but they're not really sure what else to look for. Well, the Summer Triangle is definitely one of those things that is really easy to find in the sky. So I hope that you go outside and check it out. I think we'll get you some information about star maps and then also some apps for your phone where you can find or that you can use to help find some of the objects in the sky that we talked about today, and then more. But next week, we're going to be talking about a new topic. We're going to pick another constellation. If you have a recommendation, put it in the chat, but I'm leaning towards the constellation of Hercules because we're going to lose Hercules in our sky in a few weeks because the sky changes with the seasons. We see different constellations all the time throughout the year. All right, crew, any final thoughts?
No.
All right, let's wrap it up then. Have a great evening, everyone, and a wonderful weekend. Thanks so much for tuning in. We'll see you next week, next Friday at 6:30. Take care.